Hey there guys, and welcome back. So, yesterday morning I was thinking of doing a cute little design stream where we made some linear bearings, linear block bearings. That was the plan. I want to do just a little bit of initial research just to make sure that I knew what I was looking at. You know, one of these things about what size block was I looking at, what size bearings, etc, etc, etc. Hopped on to Amazon to start off with, and the linear slide rail. Okay, a lot of this is not what I was thinking about. These MGNs was what I was thinking about. That's what I'm used to from the 3D printing standpoint, are exactly these guys. For the record, I guess I'll get it out of the way. MGNs are specific, as far as I understand it, to Hiwin, not sure of the pronunciation, Hiwin. That is their brand, or their model number is the MG series. But more to the point, as you can see here, we have linear rails right here. I should say rods, linear rods rather, came up. We have these weird hybrid things, and one of those things, the more I looked around, not specifically on Amazon, but when I came over here to just web searching, you can see we even have a lot of other things. So I ended up doing a lot more research, and that is where we're going to be at today. We're going to just go over everything I looked at, because evidently linear slide rail can mean literally anything at this point. So the main purpose, which is why I started off on Amazon yesterday, my point was that linear slide rails are expensive, relatively expensive. So to start off with, I went ahead and I put together an Excel sheet. Okay, so this is going to be full assemblies off of Amazon. The reason I'm doing this as its own block is because one of those things for Amazon, you more or less have an idea that everything on Amazon is going to be relatively priced. If we go to different websites, then different websites might have prices all over the place. But Amazon, everything should be competitive against each other, so prices should be relatively stable relative to each other. Relatively. In case I did not say relative enough there. So, just as the basic setup here, MGN-9s, that's just the size I decided to go with. That's 9mm block is the 9. The MG is the series, that's the small series. The miniature series, miniature guide MG. And then the N is the normal size, as opposed to the H or the C. I can't remember what the long size is. I'm blanking on the long extended carriage size. Now on Amazon, and the reason we have full assemblies, on Amazon it's really difficult to track down just the guides by themselves, just the square guides that the block rides on. So I decided to go with full assemblies off Amazon for this list. And as you can see, I did cheap and expensive where possible. We will get down to these guys. These guys are interesting. This is another category, but I wanted to begin with to compare the MGNs to the 2020s, which you guys have seen me use before. That's just standard i3, not even i3, but more Creality, I guess, is the ones that popularized it. And then obviously this is the 8mm rods with linear ball bearings. That is on the Prusa i3. You know, that's what we got for our X-axis and our Y-axis. So I got these three in here just so that we can get a comparison. One of those things, I did buy millimeter first and then went, look, I'm a human. I don't understand millimeter. I don't understand small numbers. So here is the price comparison in meter length, which gives us a much larger number to look at. So as we can see here, the 2020s, quite clearly the cheapest, as you can see. It's to be expected, right? It's back to the Ender, the Creality. Those are the cheaper models as compared to the Prusa. So it costs a bit more to use the 8mm rods than the 2020 extrusion with the carriage with the V wheels. And then we can see here, this is the MGN-9s. At the cheap end, it's $55, which is more than the expensive end on the 8mm rods. Per meter, per meter. And it obviously goes up a lot more expensive. So this was the point I was originally going to make in the video, that, well, let's see if we can make a DIY option as an alternative because it is so incredibly expensive. It's more than 3 times an expensive set of 2020 extrusion with carriage and V-wheels. So that was the initial point. But as previously stated, there is a heck of a lot more going on over here. So let's start digging through it. So obviously the MGNs, the 2020 extrusion, and the linear rods, you guys should all be familiar with. I mean, just as, actually I already have this pulled up really quick. So here's the MGNs mounted onto a printer. You can see they just go up against the extrusion is how they normally get printed on, hooked up to a printer. So they just get mounted to the extrusion, and yeah, I guess I should start there. So the big factor with linear rails, why they're quote-unquote preferred, is, as I understand it, they're more rigid. So if we look at this cross-section here, okay, first off, they hug the rail a lot tighter because they have a bunch of bearings going up against the rail, as opposed to a V-wheel. A V-wheel is only touching on the wheel portions, so it's slightly less rigid there. It's more likely to go out of, as far as I understand it, it's one of these things. People can argue with me. I have seen reviews that say that linear rails are not even worth it on a printer, that you may as well just use V-rails. So the other thing is all these little screw holes here. So with the V-wheels, obviously the carriage floats, and then it's a matter of whether or not your extrusion. So if you need a 20x40 extrusion in order to not bend, to not deflect, that's the word I'm looking for, in order to avoid deflection across the length with the 2020 extrusion, well, this gets bolted down to something more rigid. You know, you can choose however rigid material you need, and then you can toss a screw into each one of these little holes here, each one of these pockets, and that will keep it rigid to the more rigid surface that you have. That's for one. And for two, this also gives you an option, in theory, depending on what you're mounting it to. So the extrusion, mounting it to the printer is not as good of an example, but let's say we're mounting it to a piece of metal or something like that. In theory, you could go along the length and you can straighten out if your linear rail is not straight. You can straighten it out and put screws in to hold it straight. So those are advantages of the linear rails, which is part of the reason why it's more expensive. So again, we have this, which is what I typically think of when we talk about linear rails. And then, is it down here? Yeah, okay. This, for some reason, also comes out for linear rails. I do not consider a rod a rail. A rail, in my mind, is something relatively square, but it's one of those things, whatever they come up with. So this looks a little bit different than what we did, for example, on the sanding jig, where you have these block bearings. I have seen these around. The funny thing is I look at all this promotional material, and it all looks backward to me. And when you come down here, you see that actually it looks like I am correct, and it is backwards. As far as I understand it, and I've only ever seen the block bearings used like this, where the flat end on the bottom here, it's one of those things I can't hover and point at the same time. I guess if you look at the preview, not at the preview window, but at my cursor on the left here, you can see where I'm pointing. The flat end is normally up, but for some reason in all the promotional material, the flat side is facing the bottom, which is not where you generally put your carriage. Generally, I mean, you can technically speaking, but I'm used to seeing the flat end going up. And the point of this, of having a flat end as opposed to the LMU 8s, which I probably should have pulled up, so LMU, or 8UUs. So these guys, again, per the sanding jig, per the i3, these get zip tied, tied to, bolted to, etc. another plate. And then that plate between two rails keeps it flat. With these guys, you still need two rails because these guys, as you can see, spin and rotate along that rail, but they at least have a flat surface to mount to. So I wanted to bring that up specifically because you can get these block bearings, which are a little bit easier to mount to. They don't have to be like tied on or encased in, pressed into another object. So there's that. And then this was an interesting one that I came across because this is kind of a hybrid between the linear rods and the linear rails. Again, what I think of traditionally as a linear rail. So as you can see on the bottom here, we actually have a rail that we can bolt down, which is nice. But we're using a rod, and we're using a modified, so this is an open, as far as I understood it in my research, an open LM8UU. Now, as you can see here, we have this weird specification here. I had some difficulty tracking down SBR. Well, I didn't have some difficulty. I could not find SBR 8s actually available. The smallest I could find actually available was SBR 10s. So the SBR 8s, I found a reference on a couple of sites to it, but otherwise does not seem to be available. It seems SBR 10s, which I'm 99% sure is a 10mm rod here, so 10mm ID on the bearings, is what you're going to be stuck with, which again is a little bit bigger than the other stuff that we work with for 3D printers and smaller CNC designs here. So that is weird and interesting setup number 2. And again, this has some advantages over the linear block bearings insofar as it's actually easier to get these open LM8s if we wanted them. Again, this is not actually an LM8, it would be an LM16 because, again, the 16mm. Point being is it has some advantages here because it's easier to get these than the block bearings. The other thing, actually, I'll wait for a little bit later to go into the other advantages. Because that is actually another section that I wanted to talk about. The third kind that I found kind of interesting. Well, actually, let's see. Do I have... Okay, so I think I'll save that for a second here. So they do make outside V rollers. These are not on the Excel sheet because I cannot get a price for these guys, at least as far as I found. But it's a simple idea. Instead of having a... I'm going to say convex V-wheel, we have an indented concave V-wheel. And it runs more or less on roughly the same kind of slide as everything else. So there's that. And then, let's see. Let's hop over to the Excel sheet. And I minimize the Excel sheet so you get the blue screen. There we go. Okay, yeah, so... This one, okay, yeah, I guess I will talk about this one now. Okay. So this guy, let's pull him up and then switch you back over to Edge really quick. This guy's interesting because this is actually the opposite. So this is, this guy down here is V-wheels on the outside, like in 2020 extrusion. This guy is V-wheels on the inside. And as you can see, it's a row, and this center one is concentric. So it actually squeezes outward. This is an interesting design, especially because we could actually DIY this one. And it's simply a matter of figuring out what to do with the outside, which, as you can see here in this design, they actually put rods. So a lot like this guy right here, the SBRs, where it has a rod on the inside for the bearing to run against, because that's kind of standard, I guess. Whoops, nope, there it was. That they have these rods in here. So this is another design. Again, it's current year. Evidently, linear rail means literally anything. Linear slide rail means literally anything at this point in time. So those are buy options. And again, if we hop back over to Excel, and I did not minimize it this time, you can see those ones in particular are ridiculously expensive for the cost of length. The SBRs are actually kind of comparable to normal 8mm, but they have that advantage where they're secure across the length. So whereas with linear rods, normal linear rods, they can deflect because they have no support across the length. Again, that's the benefit of the linear slide rails, the MGNs, more specifically. Again, because linear slide rail evidently means anything. This is kind of the hybrid where it gets support across the whole entire length, so the rod does not deflect. Now, next up, a couple different DIY options. These are not specifically from Amazon. I just randomly found decent prices anywhere. And the first one, and I didn't pull this webpage up because I just have a little sample here that I keep around for the heck of it, and I've talked about this a number of times on stream. So this is actually a much smaller version. This is the version that I've played with before. and this is using 623s on a half inch rather, half inch conduit, EMT conduit. And it's basically, it looks a lot like the V-rollers, right? We got just 3 wheels in parallel, and then I got this one on top just so that it slides on top as well. This was just a sample piece that I threw together really quick forever ago, so it is not actually tuned. You can see it has a bit of wobble. You can get that wobble out. You know, it's not actually that big. It's not that loose normally, and heck, I'm pretty sure with this specific one, yeah, I can just pop it off there. One of those things. Those features are not specifically a problem. For the MPCNC, instead of using these 623s and this half inch, it uses a 1 inch EMT conduit and the 608s, commonly known as skateboard bearings. So it's a much bigger design. I have this much smaller design that I put together myself and have used in projects before, just because it's the point of MPCNC is that in theory it's cheaper, and this is obviously more cheaper. It is a lot less cheaper because I'm using a lot smaller parts, and it's one of those things, as I've said before, this EMT conduit, even at half inch, is really rigid. And if we're using parts this small, I'm not making this 20 foot long. In theory, I guess I could, but one of those things, it's rigid enough in my opinion. So that is an alternative. Hop back over to Excel. DIY builds. He's on YouTube's. He has a CNC router. He has plans for the CNC router. He actually has this interesting idea to use DIN rails and V-slot rollers. Now, a while ago when I checked on DIN rails, it was really difficult for me to get long lengths of DIN rails. Right now I can get up to 1,000 millimeters, I have found, for a decent price. But for example, with the CNC router, in theory, that is a 4x8 sheet of plywood you put on the table, which means that these rails actually have to be longer. 1,000 millimeters, a meter, is less than 4 foot. So you'd actually have to piece these together, which I'm a little hesitant to do. It may not be a problem. I may just be paranoid, but I'm a little hesitant to piece them together and then have the rollers get caught. But it uses these V-slot rollers, which it just occurred to me I never pulled up on the Amazons. So let us pull that up really quick while you're looking at it. Now, as you can see with the price, it is relatively cheap, 16. It's about the price of a cheap 2020 carriage. One of these deals where I don't know, it's a little difficult for me to say. I kind of feel like I would go with the 2020 carriage over the DIN rails, but the DIN rails, again, so there's the deal, right? The DIN rails are a lot narrower of a profile, so it does have its definite benefits. So for example, the 2020 carriage, the DIN rail gets bolted to a back plate, right? And that's what it gets bolted to, just like linear rails do, okay? The back plate, in theory, could also be bolted to 2020. You could just bolt 2020 to a back plate, and then you get that support just like you would have for the DIN rail. So it's kind of hard for me to make that comparison there. And then it's a matter of these V-slot rollers that he picked out were really, really expensive. You see up here, they were $62.45 for 20 of them, and then it uses 4 of them on the carriage, which is why it's divided by 5 here. So the ones he picked out were really expensive. You can get cheap ones, but I'm not sure what the difference is. These are all metal. They don't have the rubber coating on the outside, unlike the normal V-rollers. So there are a lot of comparisons there that do not seem quite right. And I'm just going to pull this up really quick on Amazon again because I forgot to open up the extra ones. The slot wheels. And here we go. I'm just going to open that one up. All right, cool. So back over to Edge. So here's a DIN rail for the record. You can see it's this U-shaped or C-channel kind of flanged C-channel, I guess is how I would describe it, shape. So this gets bolted up onto whatever, again, just like linear rails do. And then these flanges that stick out the side, you take something like this. Now this is the cheaper plastic ones. Again, he picked out for his design metal ones, which I assume last a lot longer. How much longer and whether or not it's worth the price difference, you know, this is 16 for 9 here. I might be able to find 20 for 9 or possibly 20 for 10 if I start looking. But point being is that if we're getting 20 in both packs, that means that the metal ones have to last at least 6 times longer, because it's 60 compared to 10, you know, round numbers. So one of those deals, I'm not 100% sure if it's worth it, but this is where we're at right now. Go away shopping. Yeah, so that is that one. That is definitely a DIY alternative option, and it's an interesting one. Next up, let's see, Excel. Okay, next up on here is the extra cheap option. So this is me buying my 2020 and then the palm wheels and then printing the carriage. So this one up here, these ones have metal carriages. This was my printed carriage. It's one of those deals where I don't have the price of the print in this one, which is why it's really low. Also, for the record, I don't have the price of the material in here because, again, it really depends how you want to build the carriage here. The fact of the matter is that you're going to end up under $1, probably, in most cases, for the carriage. So I didn't really think it made enough of a difference. But here we are at $8. Again, if we compare this $8 to the $15, you know, buying a metal one offline, off Amazon. And the other thing to be fair with is that oh, okay, actually, you know what? For the cheap option, I forgot. For the cheap option, I actually went ahead and used my price that I can get 2020 extrusion for, which is a bit cheaper than the Amazon price, because the Amazon price for 2020 extrusion is basically linear. There is no cheap options. So that is the deal there. So the price on the rail is going to be the same exact. It's just a matter of, okay, we're only buying the wheels, and then we're printing, in theory, everything else. Again, I've printed eccentric nuts and spacers before, and they work decently well. So, again, it's going to be a couple cents for an eccentric nut instead of, let's say, 20 cents. So it's going to be savings all around. Yeah, okay, I'm going to go over this right here before I circle back and start talking about DIY options for these guys, because that was the reason I actually added these guys to this one instead of just leaving it with the standard options. So we'll talk about this. So from the Maker Store, was the only place I could find where they were willing to sell you just lengths of the rail, which is important. On Amazon, I could not find just lengths of rail, which means that I could not just break this down into rail and block bearings to do the comparison that way, because it does make a difference. You know, you're only going to buy 1 to 2 block bearings, let's say, depending on how well you want to support your object that you're moving around, but you're going to have to buy a length of rail. So how much the rail costs does make a huge difference. So here we can see, for example, that the MGM blocks from the store is actually cheaper. Now this price right here is way over because of this $3.90 a wheel right here that they're selling their V wheels for. So this price is not very well reflective. The fact of the matter is that you can get a carriage, a V wheel carriage on Amazon with wheels, for a steel carriage, I should specify, with wheels for $12. So kind of ignore this one at this point. Again, because it's a store and prices off of Amazon tend to be all over the place, these prices might be a little bit higher than you could alternatively get them, but it's the only place I could find where I could actually do a straight up comparison of all the individual components, which is why we have this chart to begin with. So as you can see here, again, assuming that these are the same price right here, as it turns out, the linear bearings are actually the cheapest option here, even though you need 2 of them because you need to support on 2 sides because they rotate around the rod. So even though you need two of them, it still ends up being cheaper to use the 8 LM. That's way too many M's. The LM8UUs. It's way cheaper to actually use those and then strap on whatever you're connecting to it than to get a steel carriage or a bearing block. However, again, the big problem is these guys right here. The 9mm rails, you can see that's $70 to get just the rail. Again, relative to the maker store costs. Again, these are probably high, but relatively speaking, again, just apples to apples, $70 compared to $10.60 compared to $11. So the linear rods, in my opinion, seem to just take in the maker store as a relative baseline. Linear rods with linear bearings seem to really take the really be the way to go. The 2020 extrusion, well, I will say this, okay? As you can see, this is 500mm length right here, not 1,000. That does make a difference. To get a 1,000mm rod, unfortunately they did not have it in the store, but it would probably be more expensive than this 1,000mm. It possibly would be more expensive per meter than this 2020 extrusion. There's a possibility there. However, you do, again, save a lot of money with the bearings, so I am going to maintain that this seems to be the cheapest option. But more importantly, the rails here are the big issue. And that finally sets me up for the thing I've been circling around for a while now, which is DIY options that are not on this list, that have not been done yet. So again, the point of the linear block rails are that they kind of hug the rail and the rail gets supported across this whole entire length. This guy right here, the SBRs, the interesting thing about this, we'll hop back over to Edge and I will go ahead and pull it up. There we go. And back over to Edge now. The interesting thing I think about this that I believe should work is as you can kind of see here, the bearings are not specifically on center. They're across the edges, like they're kind of triangle. They're in kind of a triangle formation, a delta formation, whatever you want to call it, along the rod, which means that there's no bearings running directly across the top of the rod. So a DIY option I'm thinking is, in theory, we could drill through the center of a rod and just through bolt it to an object. Obviously the through bolts are going to be much smaller than these ones on the flanges of these guys, because it has to be between those two races on the open LM8UUs. But that is an option. It's an interesting idea, and it certainly is possible. So that is a DIY option for these guys. Again, the 8mm rods are relatively cheap, and the LM8UUs, the one site I found that I checked, actually put the open LM8UUs as cheaper than the closed ones, which was interesting because it seems like a more complicated object to me, but evidently they save enough on material that it's actually cheaper for the open option. So that is an interesting idea. And one of these things, another thing I should add is not obviously, but the rod would not go directly down to the ground. It would not be bolted directly to. You'd need spacers, just because, as you can see, the open LM8 block does wrap around the sides there. So you don't want the bottom of the block rubbing against the ground. So you would need to put little spacers in, but spacers, one of those things, are pretty cheap. Super cheap. They're washers or little pieces of plastic, whatever you want. The next thing is back to not necessarily this guy. This guy. So again, similar idea. We could, in theory. So first off, this design right here is super easy. Like this is a super easy design to build. It's just some of these palm wheels. I'm calling them palm wheels, but V wheels, V groove wheels specifically, as opposed to the V slot wheels. Making that distinction right now just because obviously that may not fit. Actually, that one looks like it might fit. I've seen some V slot wheels that are a lot more closed than that. Let's see if we can find another example somewhere down here. Hit the back button. Let's see. I don't know. These ones are all looking alright right now. I've seen some where the slot was very narrow. But anyway, point being is that I have also found V groove wheels that are a lot bigger. Whoops. V groove wheels that have a lot. So these are alright. This is a bad example, this search, just because these ones are all like 1 inch plus. So these are way too large for our application. But my only point being is that you can get a much more concave shape that hugs the rail, the 8mm rail, 5mm rail, whatever we end up with, which is a little bit of a question because over here on this site, the technical drawings don't really define it. I can do some guessing. For example, this is 3/4 of an inch. That's about 1/4 inch. So we got about 1/2 inch here, and it's only taking up maybe 1/4 of that. So this may be 1/4 inch right here, which puts it at about 5mm. So we might be looking at a 5mm rod going through here. And again, it's one of these deals where, depending on how we make this carriage, again, in theory, we can. So these rods are slotted into these metal pieces. I don't know how well we could print and attempt to create little brackets that hold these. So instead of printing the whole entire length, because that's difficult on 3D printer and time consuming and cost money, we could do little individual brackets and support the rod at every, let's say, 1/2 foot, every 3 inches, anything in that range. You know, we could just print out little brackets, slide them onto the rods, and then we'd be off to go. Again, this top piece being super simple, and the top piece only making contact on the inside here, and only at 2 points in theory on the inside. I don't imagine that anything we build will be perfectly rolling along the inside in here. Again, that's why I said V groove instead of V slots, because as you can see here, this groove is a lot more concave than the V slot, which is a lot more V shaped, obviously. I guess I got to go back on this one. Let's go back, go forwards, go here. So yeah, this seems a lot sharper of an angle to me than the other one in the picture. So if we do get these guys, then it would probably only be making contact just barely on the edge there, on the edges. But we should have room for the blocks. So that is the two DIY options. Again, either with the open LM8s, I lost my cursor, there we go, or with these V wheels. Those are two interesting slide options. Now, DIY options for these slide blocks themselves. First off, we would need a rail. The rail seems a little difficult to procure, again, and expensive. So just DIYing this guy right here does not seem feasible. So I don't really know that this actually is a DIY candidate. I will say that if you look at various, let's see. One thing that I pulled this guy up just because it's interesting. So again, this is basically the same thing as our V wheels on 2020 extrusion. It's just that the angle that it's grabbing at is different. However, the interesting thing about this design right here, I know I'm jumping back a little bit. One of those things, I do this without a script. So one interesting idea about this particular setup is that you can actually spread these out as far as you want. You're going to be screwing rather, to some kind of surface to begin with. So these two pieces literally do not need to be together. There's no reason why they need to be together unless you were super concerned that you were not going to keep them straight, in which case, yeah, go ahead and just do one solid thing. But it's an interesting idea that you could have two separate pieces. That is kind of like what we're doing over here with this guy, We are going to, if we do a DIY version of this, have 2 separate rods running, and then we're going to push off of them, in which case the spacing on the rods need to be exact. However, again, with our brackets help that. With this one, you actually need to measure and screw and make sure that you're screwing straight. So that's a bit of a difference. However, back onto what we were talking about here. Again, high wind, he wind, whatever. There's a possibility that these rails are only expensive because they're the patented rails, specifically for these patented blocks. You can look around the internet and find various takes on this. Let's see, really quick. I guess this guy right here. So you will find different shapes. Oh, and I did pull up in Fusion. Let's hop over to Fusion really quick. Fusione. For example, I pulled this one off of MasterCar, and you can see this profile right here is significantly different than the other one. Ignore the fact that this is a 15 model, 15mm wide model. Doesn't necessarily matter. The fact is that, again, because patents, you can find rails of different shape to get around the patent issue, and otherwise be the same exact thing, still be a linear bearing, linear slide rail. But that is besides the point. I think at this point, the conclusion I'm coming to is that these rails, regardless of where you find them, are still going to be more expensive than simply getting a 5 or 8mm rod. Again, on this design right here, I'm going to close the other one so I stop opening it up. Boom, boom, boom. There we go. This one appears to be a 5mm rod. So one of those things, again, these rods are probably cheaper than anything we can find for an actual slide rail. So that's why I'm going to abandon the idea of doing a DIY option for these slide rails, which was my original premise for yesterday's stream, which got scrapped, and we will investigate other options. Let's see, was there anything else on the list to talk about? I think that's it. I'm pretty sure that's everything, all the research options I went through. So that does mean that I guess we'll hop over to Excel. We will be, I believe, doing DIY options for these 2 designs. So the single 8mm linear rail, I know that says 12, ignore the 12 for the moment. The single 8mm linear rail using the open LM8UUs we'll do a design for, and this style here, which is 2 rails running in parallel and then V-groove rollers pressing outwards against it from the center. So those are the 2 designs that I believe I will go with. Oh, I guess the last thing I was going to mention, the last problem with the DIY option for these MGNs, or MG series, whatever you want to call them, is that I had serious difficulty, and I did not dig through that many actual CAD files, but I had serious difficulty figuring out what the ball bearings are in the races. They appear to be somewhere between 1.5 and 2 millimeters, and I say that only because the opening width on the diagrams I found was 1.1, so I'm kind of intuiting that it's larger than 1 millimeter ball bearing, and I'm assuming, intuiting that it's not larger than 2 millimeters. So the 2 sizes there that I come up with are 1.5 and 2. That's the explanation there, but it's one of these things, again, just getting the rails in order to do a DIY option on the bearing block itself is, again, not nearly cost effective. So we will be going with other options. And yep, that is everything for this stream. That is all the information I've dug up on these evidently linear rails, linear motion systems is what I might prefer to call them, just because, again, I prefer not to call everything linear rails, but linear slide rails. Regardless, that is the stream. That is what I have come up with, and that is a bunch of information that you may not be familiar with. So, let's see. Outro time. Obviously, as I mentioned last night on the chess stream, at the end of the chess stream, I opted to finish up my research on this before going back to work on the coiler decoiler. I will now be going to do work on the coiler decooler right after this stream. And after lunch, I might actually come back and do one of these designs just because I'm not anticipating being done with the, well, I know for a fact I may be done with the coding part of the linear decoiler. The coiler uncoiler. I may be done with the coding part of that, but again, I still need to actually make sure all the code works before I go on stream with it. So that most certainly will not be done before after lunch, and I do plan on streaming after lunch. So chances are we will be doing one of these two after lunch as a stream, and then later on tonight I'll figure out what I'm doing. Probably, but if I can, I'll do the decoiler. But I'm not super optimistic that it will be done by tonight after dinner. So it may be another game night, maybe another game stream after dinner. We'll see what happens. So, as always, if you have been watching, thank you, and I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.